This is our video for Chapter 3, Section 3, Prime Numbers and Prime Factorization. There are 4 terms you need to define in your notebook as you watch your video. They are factor, composite number, prime number, and prime factorization. Be sure to label the section in your notebook as terms or vocabulary, number the terms, write them down, and be sure to write the definitions. If for some reason you miss them in the video, they are in your textbook. Divisibility rules can help you find factors. A factor is a whole number that divides a non-zero whole number with a remainder of 0. This just means that if you take a number and divide it by another whole number, that it's a factor if your answer is another whole number. For instance, if we were to look at 20. Alright, I can divide 20 by 1 and get 20. So 1 and 20 are factors of 20. Alright, it's an even number, so I know it can be divided by 2. So 2 times 10, 2 and 10 are factors of 20. 2 plus 0 is 2. That's not divisible by 3, so it doesn't work for 3. 4, it has to be divisible by 2 twice, which it is, because we know it works for 2. And then 10 can also be divided by 2. So we know it works for 4. And 4 and 5 are factors of 20. It ends in a 0, so we know it works for 5. So 5 times 4. But when you're talking about how many factors something has, once you hit a repeat, you stop. So all the factors of 20 are 1, 2, 4, 5, 10, and 20. So knowing our divisibility rules from earlier in the chapter made it very simple to find all of the factors of 20. Let's look at another one. How about 24? Alright, the first factor is always 1 in the number. Let's see, 2, it's an even number, so 2 will work. So 2 and 12. 3, 2 plus 4 is 6. 6 is divisible by 3, so 3 will work. 4, we know it works for 2. And the factor for 2 is also divisible by 2, so will work for 4. So 4 times 6. It doesn't end in a 5 or a 0, so it doesn't work for 5. We know it works for 6 because it works for 2 and 3. So we have 6 times 4. But that's a duplicate of one we already have, so here's where we can stop. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. How about 35? Again, we always start with 1 and the number. Alright, it's not an even number, so it doesn't work for 2. 3 plus 5 is 8. 8 is not divisible by 3, so it doesn't work for 3. If it doesn't work for 2, it's not going to work for 4. It does end in a 5, so that means it is divisible by 5. So 5 times 7 doesn't work for 2 or 3, so it's not going to work for 6. If it didn't work for 2, it's not going to work for 8. If it didn't work for 3, it's not going to work for 9. It doesn't end with a 0, so it doesn't work for 10. So we are probably all out of factors for this number. So your factors for 35 are 1, 5, 7, and 35. Pause the video and try this word problem in your notebook. Be sure to start a new section, label it exercises, and number the problem and copy the original problem into your notebook. A gift box must hold the same number of pairs in each row. You have 24 pairs. What arrangements can you make? What it means by arrangements is, what can the different boxes look like? All you're really having to do is find the factors for 24. A composite number is a whole number greater than 1 with more than 2 factors. So what this means is it just has to be divisible by more than itself and the number 1. So say we're going to look at 6. 6 is a nice low number. Could be prime, could be composite. So we can look at it and try to do our divisibility rules to figure out what our factors are. So we know we always start with 1 and the number. Looking for 2, is it an even number? Yes. So it's going to have 2 and 3. And then the next one would be 3, and we know that's a duplicate. So this doesn't have a whole lot of factors, but it does have more than 2. So 6 is indeed a composite number. A prime number is a whole number with exactly 2 factors, 1 and the number itself. Keep in mind when you're looking at prime and composite numbers that the numbers 0 and 1 are neither prime nor composite. So let's look at a number and try to decide if it's prime. So let's say 19. All right, always start with 1 and the number itself. All right, it's not even, so it's not going to work for 2. 1 plus 9 is 10. 10 is not divisible by 3. It doesn't end in a 5 or a 0, so it's not going to work for 5. It doesn't work for 2 or 3, so it's not going to work for 6. It doesn't work for 2, so it's not going to work for 8. If it doesn't work for 3, it's not going to work for 9. It doesn't end in a 0, so it doesn't work for 10. So there are no other factors for 19 other than 1 and 19. So 19 is a prime number. Now let's try to decide if a number is prime or composite. Let's look at 51. Now a lot of times people would look at 51 and think, oh, well, I can't think of anything that's divisible by. That has to be a prime number. Well, let's look at our divisibility rules and walk through the process. Don't just assume it's going to be prime or it's going to be composite. We have to do our tests and check. So we know we're always going to start with 1 and the number itself. It's not even, so it doesn't work for 2. Look for 3. 5 plus 1 is 6. 6 is divisible by 3, so this is going to work for 3. So let's see. Excuse me. So let's see, how many times does 3 go into 51? 3 goes into 5 one time, with 2 left over, 21. So 3 times 17 is 51. Didn't work for 2, so it's not going to work for 4. Didn't work for 2, so it's not going to work for 6. Didn't work for 2, so it's not going to work for 8. Worked for 3, so might work for 9. 7 plus 1 is 6. 6 is not divisible by 9, so it doesn't work for 9. Doesn't end in a 0, so it doesn't work for 10. So chances are this is the end of our factor tree. So while there's only 4 factors, it's still more than 1 and the number itself, so this is a composite number. All right, let's look at another one. Let's see, 53. All right, so we know we're going to start with 1 and our number. Let's see, it's not even, so it's not going to work for 2. 3, 5 plus 3 is 8. 8 isn't divisible by 3, so it's not going to work for 3. Didn't work for 2, so it's not going to work for 4. It doesn't end in a 5 or a 0, so it's not going to work for 5. Didn't work for 2 or 3, so it's not going to work for 6. Didn't work for 2, so it's not going to work for 8. Didn't work for 3, so it's not going to work for 9. Doesn't end with a 0, so it doesn't work for 10. Looking like it's probably going to be a prime number. Can't think of any other factors that will go into 53, so 53 is a prime number. Alright, go ahead and pause your video. Put a number 2 in your book. You're going to be finding out whether these are prime or composite, and I expect you to show your work. Do not just say prime composite and be finished. Show your work. So let's see. 2A, tell me if 39 is prime or composite. 2B, do the same thing for 47. And 2C, do the same thing for 63. Prime factorization of a composite number is writing the number as a product of prime numbers. That means just breaking it down until you can't break it down any further. Each composite number has only one prime factorization. And when you're doing the prime factorizations, when a factor repeats, use exponents to write your answer. There are two ways to show prime factorization, or to work out prime factorization. The first one we're going to talk about is a division ladder. So let's try that for the number 84. Alright, smallest prime number is 2, so we'll divide by 2. Alright, 2 goes into 84 because it's an even number, so 2 goes into 4 2 times, 2 goes into 8 4 times. Alright, then we divide again. Alright, 2 can go into 42 as well, because it's an even number, so 2 into 42, 21 times. Alright, 2 cannot go into 21, so we'll move up to our next prime number, which is 3. Can 3 go into 21? 2 plus 1 is 3, yes. 3 is divisible by 3, so it's going to work for 3. So 3 goes into 21 7 times. 7 is a prime number, so that's our division ladder for 84. The way you would write this would be 2 squared, because we have 2 2's, then 1 3, and 1 7. So it would be 2 squared times 3 times 7. So this is our prime factorization for 84 using a division ladder. You can easily see why it's called a ladder, because we have the rungs of the ladder going up. The second way you can show prime factorization is to use a factor tree. So let's look at 84 again. Going to do a little separation symbol. We'll start with a number we know is our lowest prime number, which is 2. 2 goes into 84. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 is prime, so I can't do anything else to 2. And we're going to do our open symbol for 42. Go with 2 again. Again, 2 is prime. 2 goes into 42 21 times. Then we're going to break down 21. 21 isn't even, so it's not going to work for 2. Go with 3. 3 goes into 21 7 times. 3 is prime, 7 is prime. So there's your factor tree for 84. We're still getting the same numbers. We're getting 2 2's, a 3, and a 4. It's just a different way to work it out. So whichever one you prefer, either the division ladder or the factor tree, do whichever one you're most comfortable with, but make sure you show your work when we're doing these things. So again, the prime factorization for 84 would be 2 squared times 3 times 7. Pause the video and do this one in your notebook. Number 3. Find the prime factorization of 27. Be sure to write down the original problem, and I do want you to work this out both ways. So in your notebook, I expect to see a division ladder for 27 and a factor tree for 27. Check your understanding. 1. Vocabulary. How is a prime number different from a composite number? 2. Find two prime numbers between 10 and 20 with a difference of 2. That means find two numbers between 10 and 20 that are prime, and there's a difference of 2 between those two prime numbers. Like between 12 and 14, there's a difference of 2. 3. Which number is not a composite number? Explain. 55, 51, 82, 7. 4. Number sense. Can two numbers have the same prime factorization? Explain. Be sure you pause your video and complete Check Your Understanding in your notebook. Enjoy the rest of your evening. I'll see you tomorrow.